Okay. All right. Let's see. I don't know if this will work. See if I can. Perfect.
With an amp. 211 with the wiring kit. And we did the wiring kit for positive and negative wires.
What are you hooked up to?
Huh?
What are you hooked up to?
My car battery. They don't take very much.
Started out like, alright.
So I was gonna get a capacitor.
Then you had to get something.
It was already plugged in. I had a sub previously, but I blew it. That was my dinky, like 8-inch one. So I upgraded it to 212s.
It's not working again today.
No, that's weird. Why does it choose to work with phone but not my MacBook?
I can't blow 800 on subs.
Because they obviously
Rip
have
me.
in the basement to get them. And then you have to found that out. And they would have seen.
What'd you say?
Said I can't blow anything. It's the the girl that you get. She would have known. Right? She's probably missing for what, like, what, 2 years? I didn't get that.
Same.
Add me, listen.
That was a good idea.
All right. Well, I'll just have to turn that off. We tried. It still doesn't work with the MacBook. All right. Whatever. All right. So you have your practice guide out. Let's talk about your. We're on P1 to P4 review. Remember, test is tomorrow. I just want to make sure that we know how this works. So, all right. We are going to go to the practice test. Practice test. Problems number 14 through 24. Okay, that's what we're going to try to finish today. Remember, test is tomorrow. Now, also do today or tomorrow, I don't care when, page 53, that's the stuff we had on adding multiplying and area and volume. That stuff's due today or tomorrow. I don't care which day you turn it in, but that's due, so homework. And then this practice guide is due. You have to turn this in at some point. I prefer that you turn it in tomorrow. Okay, because you actually have to turn it in. So page 53 is due, and then your practice test. So, and the good thing is we've already done half of it together in class. So you should already have half done, unless you lost it. And then we'll do the second half today. Does that make sense? So it should be done before you walk in tomorrow. That way it's a nice review and you know what you're doing. Okay, so let's take it out. Let's look at number 14. We'll just talk about it out loud as we go here. Alright, so this is your problem. It's root 63x minus root 28x. Okay, these are radicals. Now, right now you cannot subtract these. They're not the same radical. You can multiply any types of radicals you want. You saw that last Friday, right? We multiplied and divided them. These, they're not the same radical. I know they have x's, but the numbers aren't the same. We have to break these down if you can, and maybe they'll turn out to be the same radicals. So we're going to do simplest radical form. So what goes into 63? 7 and 9. So 9 and 7, and then x. So the only real thing that I can do here is take the square root of 9, which is 3. So that's 3 root 7x. Make sense? Now the reason I'm doing that way is because that's a square root. That's why I'm breaking it down like that. If it was a cube root, you have to look at the cube numbers. That would go into 63, which I don't think would be enough. Next one, say it again. Okay, so you already know the answer because this was what, 4 times 7x? And the square root of 4, you take it to the outside, so it's 2 root 7x. Yeah, just like you said. And now I can subtract because now they have the same radicals on them. So I can just subtract the front numbers. And if there's no number up front, it's a 1. You can subtract it. So what's 3 minus 2? 1 root 7x. And technically you wouldn't need the 1, so you can just write like this. Make sense? Okay, we comfortable with that. You'll have something like that where I just give you a radical. You have to break them down and see if you can add or subtract them together. Now, if they don't work out, let's say that these turn out to be different. You're done. You can't go any further. They just don't subtract. You go as far as you can. That's what it says. Comfortable? 14? Let's go 15. Start with that one. Alright, so 15. Same thing, cube roots now, so we get some practice here. So this is a cube root, 24x y to the third minus y cube root 81x. And remember, when we start the test, I'll try to remind you that those are cube roots. When we always start the test, I always review like the problems. We go through all the instructions all together just to make sure. Hopefully I'll get this projector thing working with my MacBook. For some reason it's not pushing it to the screen. Alright, same thing, but now we're doing cube roots. So we gotta try to break these down. What's a cube number that goes into 24? 8. 8's a cube root number, yeah. So it's cube root, we're gonna go 8 times 3. And then for the variables in the back, we just try to break those down as far as you can. So most people can do those in their head. I think the only thing you can do, you can break down the cube root of 8 and the cube root of y to the third. It's just, yeah, to a y. So this is a 2, and it's a y. Because the cube root of 8 is 2 times 2 times 2, so that's why it's 2. Y, and then what's left on the inside? We had a 3 and an x. That was left in there. Okay. Does that make sense how the cube roots work? Again, you can do powers if you wanted to, like the fractions where you do like 1/3 or 2/3 or whatever you have, but this is, I think this is easy, most people can do that stuff in their head. Alright, here, let's do the same thing, we have the y out front, I don't care about that. But for the 81, I think it has a 27 in it. 27 is a cube root, is a perfect cube number. It's 27 times 3 times x. And the only number we can do is the cube root of 27. Cube root of 27 is 3. Okay? So you have to look at that cube list. So 3y, because that goes up front. And then the cube root that's left is a 3x. And are they exactly the same?
Yeah.
Yes. What I mean by exactly the same, they have to have the same letters, like variables, and radicals on them. They have to be exactly the same for you to subtract them. And in this case I can. So all we're going to do is subtract the 2 minus 3.
-1.
-1, so you can just put a -1y cube root 3x. And if you don't want to put the 1 there, you can just leave it like this. It's fine, same thing. I just leave the 1 there, doesn't hurt. Okay, if you forget the cube root on that, I count it wrong. It's wrong. It's a cube root, not a square root. So you gotta know. So that's the one thing I get a little particular on. Alright, any questions so far? That's the type of problem you should be expecting. Something like that, you have to break something down, combine them, if they can. Okay, if you're not comfortable with cube roots or square roots, make the little list off to the side, because I'm not going to put those on the board. You know how to make the cube root list, right? 1 times 1 times 1, 2, 2, 2, 3, 3, 3, and then you write down the numbers with the calculator. So you have that list of cube numbers. I usually go through 7. 7 times 7 times 7 is like 343 or something like that. That's usually the number I stop at.
Will we
Okay.
have problems like that in the future?
In the future? Nah, usually not. The highest number I've ever seen is 6 in your book. That I've assigned anyway. Alright, let's keep going here. What are we on, 16? Okay, this one is one where they're going to ask you to rationalize the denominator. So rationalizing the fraction means you can't leave the radicals on the bottom. Now in this particular problem, you have a binomial. Right? There's a binomial on the bottom. So that means we have to try to simplify this thing down. So what do we need to multiply by?
7.
On the bottom.
Yeah, whatever's on the bottom. So 7 plus root 3. You have to multiply by the conjugate. When it's a binomial like this, you have to multiply by the conjugate. So I have to multiply that to the top. Okay, conjugate is not an opposite. You just flip the middle sign. That's how you do that. Okay, so on the top, I have to distribute the 11. On the bottom, I'm going to have to FOIL that whole thing out. So, what do I get on the top if I were to distribute that 11?
77.
Nope.
No.
11 root 7.
Yeah.
And then 11 root 3.
Good. Yeah, you can't, it's like a trick question. You can't actually multiply. It's not in a radical, so you can't multiply. Okay, so the top, I can already warn you, the top is done. You can't do anything with that. The 11 doesn't go anywhere. Okay, alright, the bottom. first, outer, inner, last. And yes, I'm gonna write all of this out, because I know it's stupid, but at least some people will get to see it for the first time, because they're just not comfortable with that. So when I FOIL, I'm gonna take the root 7 times each of these one at a time. When I'm done with that, then I'll go back and I'll do the 3, and I'll do that after that. So I'm gonna actually have 4 items at the bottom. So I'm gonna do all the green part first, and yes, you can multiply them, they're in radicals, you're allowed to do that. Okay, so root 7 times the root 7.
7.
Yeah, because it's root what, 49, 7 times 7 is 49, and that does turn out to be a 7, I know that. Root 7 times the root 3,
Root 21.
root 21, and it's positive, right? Now, we'll go on to the red part. Okay, red part. Negative root 3 times the root 7,
Negative 21.
negative root 21. And negative root 3 times a positive root 3,
Negative 3.
root 9, which is 3, like you guys are saying. Now, the reason why I do this, I like to show you, I'm doing first, outer, and last, and yes, the middle terms do drop. That's just because they're positive and negatives, that's how it always works when you pick a conjugate, the middle should always drop. And you guys are already saying all these nice numbers that, you know, these numbers actually simplify, because it gets rid of the radicals. So, that's 11 root 7 plus 11 root 3 on the top, and that's what, 7 minus 3? And so your final answer is this. That's it. Now, if that 4 could go in each of these, you try to divide those out. But it has to go in both for you to divide it out. Okay, right now, the 11s, 4 can't go into it, so you're done. Don't make them decimals, just leave it like that, you're done, move on. Okay, are we comfortable with the type of round that can sit there? I don't even care if that was just a normal 7, like just a regular 7 minus root 3, you still have to do the same process. You have to multiply by the conjugate. Okay. Any questions, comments, concerns about that problem, something that you're not understanding or you want to see a certain example of? Okay, I'll accept your silence as either you're scared or you just figured it out. Alright, now we need to talk about the next one. I think you had maybe one of these in your problems, in your homework. It's just a problem where I just ask you to simplify it. That's all I'm asking you to do. Evaluate that problem, where you're trying to take like a 4th root of something. Okay? And I want to make sure that we understand how this works. On this problem, this is what, 17? Is that right? You're taking the 4th root of a negative 2 to the 4th. The first thing you should do is put the power 4 on the negative 2. That's what you're doing. Okay? So, if I put a positive, or a power 4 on a negative 2, this turns out to be negative 2 times negative 2 times negative 2 times negative 2, which turns out to be a 16. And now you're going to take the 4th root of 16. Notice it's a 16, not negative 16. And what is the 4th root of 16? What number do you take times itself?
2.
To 2. Now this seems weird. That's your answer. It's not negative, it's positive. Because the 4th power cancels out the negative sign. That's how it works. Here's the shortcut. The root and the power 4 literally cancel each other out. But the problem is you just need to realize that your answer has to be the positive answer. Whatever's on the inside. Has to be positive because you put something to a 4th power, so it's positive. Does that make sense? So I don't even care if that was a 5, a root 5. I think you had one of these. That means these are going to cancel out and your answer is 2. Like that's how it works. Now the only weird part about having a 5, if that was a negative on the inside, guess what? You have negatives on the outside. Because powers of 5s can keep negatives. Okay, are we comfortable with that type of problem? Okay, it'll be something like that. I'm just going to give you a problem where there's a power or something. I want to see if you can make common sense of it. Something that's not a cube root or a square root. Something bigger. That you can actually take a radical of. Okay, we're on to 18 and 19. These are the ones with the powers where they're fractions for powers. So can somebody tell me problem number 18, please?
72x 3/4.
Okay.
All over 9x 1/3.
1/3? Okay. This is a normal problem like you saw problem, what is it, problem number 9, 8 or 9? On that first page, is it 10? The one with the fractions, what, is it 9? Okay, it was that one, that problem, okay? Where you just have a fraction with numbers and variables top and bottom. Don't overthink it. It's numbers and variables. So, these two can simplify. What do they have in common? Nines. Divide them both by 9. What do you get?
8
8, and what do you get on the bottom?
and 1.
A 1. You divide them both by 9s. 17 divided by 9, 9 divided by 9, it's still a fraction. Alright, for the variables, which one's bigger? Top. There will be x's left on the top. I'd say no. And guess what you do? You subtract them. So I'm taking the top minus the bottom, right? Because I'm taking away 1/3 from the bottom. So I'm going to subtract 1/3 from the top for those x's. I know it seems weird, you have fractions. It's fine. How do you subtract fractions?
Get the
Make a
same
common
denominator.
denominator.
Common denominator. So off to the side, this is what I'm doing in my head. This is what I'm doing in my head, because I know I'm subtracting these. I'm getting a common denominator between 3 and 4, which is 12s. I multiplied a 3 here to make 12, so I have to multiply a 3 to the top. Multiply a 4 here, so I have to take a 4 times the top. And now what do you get when you subtract?
5 12s.
5 12s. Okay, now technically I don't even need the 1 on the bottom. It's not a big deal, because the 1 just goes away. But, does the instruction say anything? Are you supposed to leave it with a fraction, or does it want to put it back in the simplest form? What does it want?
Simplify.
Yeah,
Simplify.
using
So it wants you to simplify this problem down if you can, maybe make it back to a radical. Okay, so the 1 would go away. So right now we're sitting at this. If you could simplify that, like the fraction, like 5/12, make it a mixed number, that's fine. Right now I can't, it's not a mixed number. So I'm just gonna make this back to a radical. That means 8's out front, you have a radical, and what type of radical do I have? 12th root. That's what the fraction means. The bottom number means the radical. The top number is the power on the variable on the inside. This is your answer.
Oh, I forgot about that little streak.
That's your answer. And I don't even care if you wrote it like this or like this. This is still the same problem. That means the same thing. You could put the 5 inside with the x, or you can put it on the outside of everything. Because that does mean the same thing.
So will it be wrong if we leave it as 8x 5 12s?
I prefer that you go back to this. Now, it is technically right, but I do prefer that you go to that.
Okay, good.
That's what I prefer. Because sometimes this fraction can be simplified. You can take a radical, that's why I want you to go further.
Oh.
So. Okay, now, let me explain like if it can be simplified. Let's say that this turned out to be like, and this just, again, this is just a random example. Let's say it was like 8 to the x to the 15/12. Say it's that. Well, then that means I can make that fraction a 1 and 3/12, which simplifies to be 1 and what? A 4th? Because that's 3/12. That can be simplified. And this means that I have 8 and an x out front, and I have a radical with an x with a 4th root on it, with power 1. Because there's one full x on the outside, and on the inside there's a x with a power of 1 and a 4th root. This is like the simplified version of it. That's how you do fractions at the very end. Okay, any questions with that? If you had something where you could simplify like the mixed number. I know we didn't have one there, but. Okay, what do we got, 19? 19 is almost the same problem. Do we wanna say it out loud?
In
Parentheses.
Okay.
Okay, I'll let you do it.
2y 1/5, and then out of the parentheses 4th root, or I'm sorry, like
A
4.
4th root like that?
Yeah.
Okay.
And then all over y, and then 3 times.
Now, is that 4 just on the top or is it on the bottom as well?
It's just on the top.
And the parentheses
Yeah.
just on top.
Sorry.
Boom, like that? No, that's fine. Just a 17. Okay, that's it. Okay, first thing we gotta do, we gotta distribute that power 4 to the top. Okay, I'd like to do that first. So I'm gonna put the power 4 here and here. Now when you distribute, what does distribution mean?
Distribute it to all of it.
To everything, and distribution means to multiply. if there's a
Oh,
power.
sorry.
So, yeah, so the idea is that you're gonna have 2 to the 4th, cause, I mean, there's nothing you can do with that. But then when I multiply the 4 to the 1/5, you get 4/5. Now, why know that? When you multiply a 1/5 times 4, it's 4/1. That's why it actually multiplies, you multiply straight across, that's why it turned out to be 4/5. Or the trick is just multiply to the top, simplify to the bottom, that's just how it works. Okay, and then all over y to the 3/10. Okay. It's still the same problem you just did. It's the exact same problem. This 2 to the 4th turned out to be a 16, y to the 4/5, x to the 3/10.
So why did the 3/10 no?
Oh, y, yeah, sorry.
That's fine.
Y to the 3/10. It's still the same problem, you're still canceling. Which one is more, 4/5 or 3/10?
4/5.
4/5. So that means you're gonna take away 3/10 from the bottom, take away 3/10 from the top, because they're the same. And now you can get common denominators, you subtract, it's still the same problem that you just did. And you can simplify that out. Any questions with that? I think it turned out to be like a half or something like that. It was like 5 or 10 at the very end for the y. Alright, any questions with those two problems, 18 and 19? I think you have those in your homework, so no worries there. They're like the last few. Okay, let's turn the page. Now we have 20, 21, 22, 23, and 24. Alright, this is the stuff that was literally in your homework, page 53 stuff. In fact, you probably even recognize them. They're problems I picked right from the book. Because that's how it works. That's how your test works. I picked a problem that was in your homework, put it on the test. Or a problem that looked identical to it, so I'm not trying to give you any trick questions. Okay? So, let's talk about that. Okay. Let's talk about number 20 first. I think there's a couple different instructions on 20. They ask you to combine the following polynomials, like add and subtract them, and then write it in standard form, that means least to greatest, you know, like descending order, that's what it means to be standard form, and then tell me the degree. Degree is like what is the highest power, that's all it's asking. Okay, because I think on some of those problems you might have to do that. Okay, so, can somebody give me that problem, what do we have? We have a parenthesis,
5x squared
okay, keep going,
minus 7x minus 8
8, then we have a parenthesis plus,
plus 2x squared minus 3x plus 7, and then close parenthesis, minus x squared minus 4x minus 3.
like that, right?
Yep.
Okay, first thing I do, I don't need that parenthesis, don't need this parenthesis, I can get rid of the parentheses, but back here,
The negative one.
yeah, you have to distribute the negative sign. Negative sign is attached to the back parenthesis, you have to distribute it. You have to do that, I think, for those later problems where they have, you're subtracting for volume problems. So this turns out to be a 5x squared minus 7x minus 8 plus 2x squared minus 3x plus 7, and then I'm gonna distribute the negative sign, so this is what I get.
Combine like terms.
Okay, and now I can combine like terms. Yeah. So right now the like terms are definitely the x squares. X with power 2's on them. So what do we got? 5, 7, minus 1, 6x squares. Okay, those are done. Okay, what about the x's? So let's combine those. So we have -7, -3, +4. What is that? -10 plus 4 is -6. X squares.
No, just an x.
Oh, x, sorry. And then the whole numbers in the back. We got whole numbers 8, 7, 3. So what? That's a -1 plus 3, what is that, a +2? Okay, there you go. Actually bugging me, I didn't put that in the right color. There you go. Is that what everyone got? Now that is descending order. The reason why that's descending, x squares first, that's your biggest power, going down in powers of x's until you get down to whole numbers. If you have a bunch of different letters, I don't really care anymore. Just put them by powers of x's, that's usually how it works, but it's not a big deal. What's your degree of this thing now?
7.
Second, it's degree 2.
Oh, duh.
Degree 2, that's your highest power of x's. That's just how it works, that's degree. The reason why they have you do that is later on in the book, when we're trying to actually solve polynomials, like find potential roots, this thing is telling you that you have potentially to have two different roots on this problem. That's what the degree means. There's two potential spots. So that'll become a big deal in chapter 1 when we start graphing stuff. So we'll come back to that idea of degree. I think you have to do it in your homework, that was due page 53 stuff. Okay, any questions with 20?
Nada.
Okay, 21, let's talk about that. Can somebody give me that prompt?
Parentheses.
Okay.
2x minus 3. New parentheses.
Okay.
X squared minus 3x plus 5.
Like that?
C.
Distribute.
Yeah, you have to distribute. You have to FOIL first, add, and last, or distribute. It's a distribution problem because it's a binomial terms of trinomial. If you do this correctly, I should have 6 items across the board, because it's 2 items and there's 3 items, so 2 times 3 is 6. And then you should be able to simplify. The reason why I know I can simplify, these items in here are literally found in this back parenthesis. So I know it should simplify in the very, very end. That's just kind of how I can put it together in my head. Okay, doing this, I'm gonna take the 2x times each of the items one at a time. And once those are done, then I'll move on to the -3, and I'll do the same thing. I'll distribute the -3 to everything. And I'll try to color code as we go. Okay, but somebody just walk me through this. 2x times an x squared.
2x squared.
2x cubed, yep. 2x times a -3x.
Minus
And a 6x squared, yep. 2x times a 5.
Plus 10x.
Plus 10x, alright. We good with the first 3 items.
Yeah.
Now let's do the second items, the ones in blue here. -3 times an x.
Negative 3x squared.
-3 times a -3x.
Plus 9x.
Plus 9x, yep. And the -3 times a 5.
Minus 15.
Minus 15. Alright, you see, there's 6 items there. We can combine them now. I think you're fine and dandy doing that. Does it have any like secondary questions? Does it ask you to like find degree or anything like
No,
that?
just find each product.
Perfect, done. Move on to the next one after you simplify. Okay, I don't think I need to worry about that. Now comes 23, or is it 22? That's a tough one. That's the one we need to discuss.
Parentheses, brackets.
Yeah, there's a parenthesis, it's like a bracket, right? Alright, so bracket, what do we have?
5
5y
minus
Yeah.
parentheses 2x plus 3
Alright, 2x plus 3. Now, is there a plus in front of that?
No.
minus.
Is minus like that? Is that right?
Yeah.
Okay, cool. Alright, and then back here, it's basically the same thing, but now there's a plus. Alright. The first thing you need to do before we even start, because I know it wants you to multiply these things. I know we're gonna have to like distribute all this mess. We need to get rid of those parentheses in the parenthesis idea. So, this one back here, I don't really need these parentheses. This is unneeded. It makes no difference with this one. So this bracket, I'm gonna leave it like this. Because it doesn't matter, the plus sign doesn't change anything. But up here, I'm gonna distribute the negative sign. That I have to take care of first. So when you distribute the negative sign, this is what you're gonna get.
Minus 2x minus 3.
Yeah. You need to do that first. Now that I just get to normal brackets, these are actually just normal parentheses, now you can distribute. How many items will I have across the board?
9.
9. 3 items in the first parenthesis, 3 items in the next parenthesis. You should have 9. These things should simplify. It should, because the items are literally identical in the first parenthesis to the back parenthesis. I know things will combine. They're actually almost like conjugates of each other, because of the way that the plus and minus signs work. So lots of things might cancel here, but we should get to a couple items left in the very end. So I'm gonna try to color code as we go. I'm gonna take the 5y times each of these items one at a time in blue, and then I'll do the 2x and then the -3. But we'll try to color code as we go. 5y times 5y.
25y squared.
5y squared. 5y times the 2x.
10xy.
10xy. It doesn't matter the order you put those letters. They're in the back. I don't care which order they are in. It doesn't make any difference. They're the same. Okay, and then 5y times a 3.
15y.
15y. Alright, those are the first 3 items in blue. Do we feel comfortable with that? Okay, let's move on to the second items now. The -2x times each of the items in the back, just like you did a little bit ago. So now you gotta worry about it. It is -2. That is a -2x. So -2x times a 5y.
Negative 10xy.
-10xy. Okay? -2x times a positive 2x.
Negative 4x squared.
-4x squared. Negative 2x times a 3
Negative 6x.
equals 6x. Okay, we good with the negative signs? Now we have to do the last ones. Let's put the negative 3 here. This is ugly. Negative 3 times everything. So negative 3 times 5,
Negative
15y.
15.
Negative 3 times 2x, negative 6x. And negative 3 times positive 3 is negative 9. Alright, there's your 9 items, and they're color coded blue, green, black. Combining like terms, there's a bunch of stuff I can cross out here. I can see that right now. The x, y's here, the 10s, those are gone. Positive, negatives, those are gone. The y's are gone. And I think that's it. Don't cancel out the 6 x's. They're both negatives, so no worries there. Yeah, we should be good. So just combine things down, we'll be fine. So what's left over? What do we have? 25y squared
Minus 4x squared.
minus 4x squared.
Minus
And now,
all the x plus, or
Minus
minus
9.
9.
boom, done. Move on to the next one. I don't care, like you leave it like that, it's fine. I like it. If you rearrange, put like the x squares first, then the x, then the y, then the 9, that's fine. It doesn't matter. These are all the same thing. I'm not a big stickler on these problems on like descending order of x's. It doesn't make a difference to me. It's the same problem. Okay, are we comfortable if I gave you something where you had to, foil big?
Yep.
Okay. The thing I can warn you of, that would be a perfect problem to put one of those where I put a power in parentheses. Like, put a parentheses like a 2 plus 3x or something like that, and put a power of 3 on it, on the parentheses. Because now you gotta foil like 3 of them together. That'd be like a perfect problem. So you could use Pascal's triangle, or you can do this type of thing. Okay, that's just the concept. I'm trying to get you used to doing like bigger problems. Okay, are we comfortable with both of those? 21, 22? Okay, now on to the area and volume problems. You probably recognize these. They're literally the problems that you're building. This whole page has been. But those in particular, okay? Let's start with the, what is that, 23? The rectangle there?
X plus 9 times x
Okay,
plus
alright, let me erase this. How much time do we have?
Not
We have
much.
5 minutes, we don't have a lot of time, so I gotta kind of book it.
2. In parentheses, x plus 9.
Alright,
Parentheses,
so,
That's
box, alright, so give me the top one,
X plus 9.
x plus 9, side one,
X plus 3.
inside side,
X plus 1. X plus 5.
okay, like that?
Yep.
Okay, and they want this area, hopefully you can see that, this is the area they want. So what you gotta do is you gotta find the area of the big thing, subtract out like the pool in the middle. So the area of the big item is the length times width, in no particular order. And then I'm gonna subtract the area of the pool on the inside of this. Okay, what I would do, I would FOIL this out, FOIL this out, and then distribute the negative sign to the back. That's the pool. That's what I would do. Is there any questions on how you need to start that problem?
No.
Okay, I'm gonna leave that to you, because I think that one's fairly easy. Let's talk about that volume problem now. That one always causes issues. Okay, so we got volume, so we have that cube looking thing. Going to the back, we have the Jenga piece missing out of it, and that's a deep trench too. Okay, something like that. Alright, and so we give this side dimension.
X plus 2.
X plus 2, bottom,
X or 2x plus 1.
2x plus 1. Going to the back,
X plus 5.
x plus 5 going to the back. Alright, now, what are the dimensions for this thing?
3 and x. 3 going up and down. X going.
3. Okay. So, what we need to do is we need to find the volume of the big picture, and we're going to subtract the Jenga piece that's missing. The volume of the big picture is width, length, depth. That's the idea. Width, length, and the depth going to the back is x plus 5. That's the big picture. Then I'm going to subtract the Jenga piece. The dimensions of the Jenga piece is 3 and x, and the depth going to the back, which is the x plus 5.
Easy.
So that's what you have to do. So what I would do first, FOIL these together, distribute whatever you need to do, get this item, FOIL, distribute this together, then distribute the negative sign. And there should only be like 2 items back here, but you're going to have to distribute the negative sign too. And then you should be able to combine. Okay, I know that I have an answer key, it's already done, made, I did it this weekend, just make sure if you wanna check things. Okay, when is this thing due? Tomorrow, okay? Test is tomorrow, when you walk in here, desks will be definitely moved. I usually spread you out, I move the desk so like rows are facing towards my desk. I put like 3 feet of space between everything, so you have plenty of room. There'll be nothing on the board tomorrow, nothing, no perfect squares, no cubes, nothing. So you gotta come in with a mental game ready to go. When you walk in here, you can hand in your practice test, make sure you staple it together, put your name on it, and then turn in your page 53 if you haven't already. Okay, I think grades will be updated tonight, I just need extra scores, that's all I need to do, I grade this week, so. That'll be in tonight, and especially if you redid something, I'll put those in. Okay, any questions? Okay, now if we don't get the test done tomorrow, it's not a big deal, quiz, whatever you wanna call it, we'll just continue Wednesday. I'm not stressed, we don't need to get it done in one day. I'm not that big of a stickler, I just wanna make sure that you're comfortable, you go at your own pace. Okay? Question? Yes? Okay, alright. Alright, that's pretty much about it.